Hey, welcome back everyone. This is me, Rooney Lin, and today I'm going to create another educational video here on brilliant.org. But first of all, I'd like to say the previous week is over. So here, well done. You finished in 8th rank and kept your spot in the Tungsten League. So another ongoing week is going to be the same Tungsten League once again. Going to compete with other players, competitors here on brilliant.org, regular weekly leagues. And surprisingly, even better news is calculus level 3. I'm just approaching to an end, going to do some level review. You're about to level up. So after this level 3, advancing to level 4, so doing this review with lots of infinite number of exercises, I'm going to encounter each question step by step. You will probably discover how I proceed this and going to explain it completely in this educational video. So let's dive this straight into it, shall we? So I'll click here, start to begin the level review exercise after all. Yes, there we go. First question I'm going to encounter is, at which point on f to the function of x is the second derivative negative? Derivative negative is one at the maximum point. Yes, so maximum point, this one. Only this is correct. Let's check. Yup, that's correct. Let's click Y. If second derivative less than 0 at critical point is the local maximum. All 3 points at first derivative equals 0, but only 1 is the local maximum, so this one as required. So I've correctly answered it right. Continue. How many minima does f to the power of function of x have? Critical points at x to the plus minus 1 and second derivative 6x. Minima, there's only one. The same question I've previously encountered. Let's check it. Yup, correct again. Let's click Y. Since we know second derivative is 6x, we can find its value at each critical point. X positive 1, then positive 6. If negative 1, then negative 6. However, since second derivative must be positive as minimum values, only one minimum here, x equals 1. That's right, minimum values. Alright, just previously explained the previous question, the similar one I've just encountered. Anyway, click continue. Okay, which graph is the second derivative? F has a local maximum at -1 and -1 is 0. Maximum second derivative is negative. Negative as -1. Yes, this one. Let's check. Oh yes, correct again. Let's see why. By the second derivative test, less than 0 local maximum, only graph where at -1, second derivative is negative less than 0 here. Only one is correct. Lucky that I've got 3 out of 3 right so far. Let's click continue, by the way. Another question. Which graph is second derivative? Local minimum at x equals 0. First derivative is also 0. Minimum, so it must be positive here. The same question again, seems like, isn't it? Let's check. Yup, correct again. Let's click Y. Yes, similar explanation by the second derivative test. If greater than 0 at local minimum, only graph where at second derivative equals 0 is greater than 0. Only positive, so this point is only correct. All the others are negative at x equals 0, so all eliminated. This is the only correct option. So continue. Okay, select all points where derivative is equal to 0. First derivative equal to 0. Only two values, here and here. Let's check. That is correct. Let's see why. Derivative 0 when the tangent line is horizontal here, which happens in only these 2 points of normal f to the function of x. So again, Similar explanation, simple as that. Stationary points he in normal after the function of x curves that you've already demonstrated. Continue. Which point is the saddle point? Saddle point is kind of this one. I think that's it. Decreasing that increasing gradient. Let's check. That's correct. Let's see why. At saddle point, first derivative is 0, but the point is not a local maximum or minimum. Oh yes, I just assumed it correctly, so I got the right assumption. Neither local maximum or minimum, so saddle point, not this one, local minimum, but around here. Only that's correct. Continue. Find the global maximum and global minimum. Global maximum should be this. Global minimum should be this. I think that's those 2 points are correct points explained here. Let's check. Uh-oh, that's not correct. Let's click Y. Oh yes, global maximum equals a critical point. There's only right answer. This one. Global minima left edge of the domain. Oh yes, minima is farther least, not this point. I incorrectly assume it. Should be this maximum highest point and global minimum lowest point. All right, one mistake, but okay, I'll probably have to learn a lot from that. Anyway, continue. What is the inflation of point F? Inflation, yes. First to the power x and second derivative is also 0. So only x equals 2 satisfy both equations. Let's check. Oh yes, that's correct now. Let's see why. Inflection points at x equals 2, cause 1 less than, x is less than 2, second derivative less than 0, opposite greater than 2, second derivative is greater than 0. So this point, stationary decreasing gradient and then increasing gradient. So 2 simple graphs that also explain why this is the inflection point, the true variable of x. Continue. What must be true about this? Wait. F to the power of 3 equals 1. First derivative of f. Let's see. Since like is stationary less than 0, so the opposite might be, yeah. Wait, let's see. Which one is correct? I just couldn't remember. So I think opposite way around. Greater than 0. Let's check. Oh yes, that's correct now. Let's see why. Since F3 second derivative of f define concavity of f. Concavity at x equals 1, so is the symmetrical curved line explain that the derivative must be greater than 0. So like this way, then opposite way around this way. Okay, symmetrically opposite way around. Okay, I assume it correctly. Anyway, let's click continue. Okay, set the interval where f is concave up. This is second derivative. Concave up means, wait. Concave up, I think there's only one of the interval here. It can't be less than 0 cause all are convex. So concave is only this range, greater than 0. Let's check. Yup, that is correct. Let's see why. Graph of f with concave of only one second derivative is greater than 0 happens only in this first interval. Alright. Also, this is my correct assumption. Lucky to get it right. Click continue. I think the last one I'm going to encounter will show up. Set the interval, okay, where f is concave up. Again, the same question that I previously encountered, so second derivative, so it must be greater than positive. Only this one applies. Let's check it again. Yup, that is also correct. Let's click Y. Graph of x once again will be concave of only once second derivative is greater than 0, so only the second interval is the correct answer to this encounter question. But anyway, I've already encountered lots of questions and only minor one single error that I just failed to recognize. But anyway, level review, every single question on my way is complete. I've just successfully completed this level review and going to click finish tab to conclude it. Wow, level complete. After completing this level level review of calculus questions that I previously demonstrated, I've gained total 160 XP this time around. Well done to me. Let me applaud myself. As you look at this, like, it's actually level 2, okay, not level 3. Don't have to be mistaken. Anyway, click continue. A fortnight. Actually, this fortnight means 2 weeks. Big streaks deserve big awards. Okay, successfully completed this 14-day streak. Like, currently 4 days in a row after today exercise Monday. Like previous week, I've given a couple of days break, like here on Thursday, re-energized, then today on Monday. Like, keeping this brilliant draw has kept me this streak for 14 consecutive days, so another remarkable achievement, isn't it? That's all I want you to know, how my progression has been going better and better. Anyway, continue. Yes, excellent. You finished 8th rank, keep your spot in the Tungsten League. That's already I explained to you earlier before I began this exercise. So I'm not going to repeat that anymore. Anyway, continue.
Mistakes happen.
Okay, that's just... Sorry, I just mean like this. Brilliant.org keep showing me ads. Like some just want to see this ad cause it's just hilarious. Like, kind of, you don't have to consider watching these ads anymore, but just leave it all. And again here, level up your learning with premium, but I'm never doing premium, just basically free account as usual. So remind me later. Alright, there we go. This is actually not level 3 review, back in level 2. So in calculus, I've advanced to a new level here, new stage called level 3, finding derivatives. And the exercise constant multiples, although I might not potentially record these videos because they are a little too simple to explain to you. But anyway, that's it all for this educational video that I've created today to all of you. So thank you very much indeed for watching, and if you do so, don't forget to add a like and subscribe to my YouTube channel that's called Runilin to discover other educational videos as well as similar content creating videos that I've described to you earlier. But anyway, that's it. Not for the end of the Brilliant.org journey. I'll still continue stay tuning, recording these educational videos to make you more interesting. And yeah. Anyway, that's it for today. I'll see you in the next video, guys. Take care. Cheers. Bye.